So here is another question on temperature measurements and temperature scales. So it is given that in a liquid thermometer, the mercury level is at 75 centimeter at 0 degrees Celsius, 100 centimeter at 100 degrees Celsius and 80 centimeter at room temperature. Find the room temperature. So if you remember, we discussed in detail the different types of thermometers, constant volume based liquid and glass thermometers, then we discussed electrical resistance and thermocouple based or thermoelectric thermometers. So there, in case of liquid based thermometers, okay, for liquid thermometers in which the liquid which is commonly used is mercury, the temperature, if in order to calculate the temperature, it is a function of the mercury level. So it is given by the specific temperature T is equal to the mercury level at that temperature LT minus the liquid level or the mercury level at the lower fixed point by the mercury level at the upper fixed point minus the mercury level at the lower fixed point multiplied with the difference of temperature between the upper fixed point and the lower fixed point, this. So here everything is in Celsius, so it's better that we convert it into Celsius with the upper fixed points and lower fixed points with respect to Celsius scale. So it will be LT minus L0, the lower fixed point is 0 degrees Celsius, the upper fixed point is 100 degrees Celsius, the lower fixed point again is 0, and here it is 100 minus 0. So here the liquid level at 0 degrees Celsius is equal to 75 centimeters. Liquid level at 100 degrees Celsius is equal to 100 centimeters. And the liquid level at the specific temperature, which is the room temperature, it is equal to 80 centimeters. We have to determine T. So here we'll only substitute the values. So that implies T is equal to 80 minus 75 by 100 minus 75. So it is equal to 5. Yes, I forgot one thing. It is into 100. This is into 100. So this is equal to 5 by 25 into 100. This 5. So 100 by 5, it is equal to 20 degrees Celsius. So multiply this difference TUFU and TLFU, that is 100 into 100. This is, we have multiplied it 100. So that is equal to 5 by 25 into 100, 1 by 5 into 100, that is equal to 20 degrees Celsius. So the room temperature is equal to 20 degrees Celsius. Simply just put the values and get the answer. But the important thing here is to recall the formula and to understand that this formula is applicable for this question. So that is the objective of this question, to recall the formula and to have the understanding that this is the applicable formula for this situation. Okay, so this is it. So here is another question on temperature measurement and temperature scales, that topic. So it is given that a platinum resistance thermometer has a resistance of 10 ohm at 0 degrees Celsius and 20 ohm at 273 degrees Celsius. Find the temperature coefficient of resistance. So we have discussed the platinum resistance thermometer or electrical resistance thermometer in our discussion related to different types of thermometers used for temperature measurement. So there we studied that the electrical resistance thermometer, the relationship between resistance and temperature, it is given by this equation. RT is equal to R0 into 1 plus alpha into T minus T0. So here T is the specific temperature which is to be measured, or the reading which is taken. At the specific instantaneous value of the temperature. T0 is generally 0 degrees Celsius, okay, one of the reference points, and RT is the resistance at temperature T, okay, temperature T degrees Celsius, and R0 is the resistance at 0 degrees Celsius, okay. So alpha is the temperature coefficient of resistance. So in some cases you will also come across equation like this: RT is equal to R0 into 1 plus alpha T minus T0 plus beta T minus T0 whole square, like that. But unless and until it is mentioned specifically in the question to use such a equation, this is the standard equation, okay. For if nothing is mentioned, this is the equation which is to be followed, okay. So here we'll do this because nothing has been mentioned like that. So here we'll not use this one, we'll use this one. So here what is given? It has a resistance of 10 ohm at 0 degrees Celsius. So R0 is given. R0 is equal to 10 ohm. Then R20, which is equal to 273 degrees Celsius. So T is equal to 273 degrees Celsius. T0 is equal to 0 degree Celsius. So that implies if we use this equation, we have, if we simplify it, it becomes RT is equal to R0 plus R0 alpha T minus T0, okay. That implies RT minus R0 is equal to R0 alpha T minus T0. We are simply just simplifying the equation. That implies RT minus R0 by R0 into T minus T0 is equal to alpha. This is the equation to determine alpha. So we'll simply substitute the values. So here we'll simply substitute the values. Here will be alpha will be equal to R273 minus R0, because T is equal to 273 degrees Celsius, by R0 into 273 minus 0 degrees Celsius. So substituting the values, R273, resistance at 273 degrees Celsius, that is equal to 20 ohm. Resistance at 0 degrees Celsius, that is equal to 10 ohm, by R0 again 10 into 273 minus 0. So 20 minus 10 is 10. So, and here the 10 that gets cancelled. So we have 1 by 273. Okay, 1 by 273 degrees Celsius verse. Okay, or 1 by 273 per degree Celsius. This is the temperature coefficient of resistance for this platinum resistance thermometer. Okay, so this is the thing.